Sea level is rising about 3 millimeters a year, and the rise is increasing due to glaciers melting and ocean thermal expansion. The International Panel on Climate Change, or IPCC, provides reports every 7 years with estimated potential global sea level rise on the basis of 1. The observation of environmental changes, and 2. Considering different greenhouse gas emission and mitigation pathways. But the uncertainties in such predictions are large because we lack enough knowledge about how the Earth's system functions. Antarctica, the largest mass of ice on the planet, and a large source of ongoing and future sea level rise. How vulnerable is Antarctica to ongoing climate warming? The Scientific Committee for Antarctic Research, or SCAR, has addressed these questions through the Past Antarctic Ice Sheet Dynamics Programme, PAIS.
Bringing international scientists together to work in PAIS has really generated world-class science.
You know, when PAIS started, we already knew that the West Antarctic ice sheet was vulnerable. There was still the idea that the East Antarctic ice sheet was still very stable. And to me, one of the main things in PAIS is that really has proven that the East Antarctic ice sheet sensitivity during past high CO2 concentrations also contributed to the global sea level. So it also is vulnerable.
PAIS has helped us.
When PAIS started,
PAIS has carried.
PAIS stands for
PAIS evolved out of a prior
PAIS
program.
means to me Past Antarctic Ice Sheet Dynamic.
What does PAIS mean to me?
Keep bringing together big minds, young minds, and brilliant scientists.
Collaborative, interdisciplinary research within a supportive network of colleagues and friends.
Togetherness. You know, we are sitting thousands of kilometers apart, but the language of science transcends everything.
Because Antarctic science cannot be done by a single country or a single person.
PAIS coordinated a large scientific community with different skill sets by facilitating the planning of new data acquisition missions and using emerging technologies, targeting scientific knowledge gaps, encouraging infrastructure development and data sharing, initiating and expanding cross-linkages among Antarctic research communities, and by training and engaging with students and early career scientists.
Past Antarctic Ice Sheet Dynamics Program, which we call PAIS, is to better understand how the Antarctic ice sheet is going to respond to climate change, and particularly as the world warms. So what we do in PAIS is we use geological information. We go back in time to past warm climates, and we try to understand how the Antarctic ice sheet responded. How much did it melt? How much did it contribute to sea level rise around the world?
We basically are discussing recent results and how to develop new program to create some sort of cooperation to work together to share efforts, results, data, and of course the cost for the logistics, because going to Antarctica, which is a very remote place, is very expensive, it's very demanding. So we want to, but it's also good to have a sort of cooperation.
This is an example of an excellent form of scientific evolution. PAIS evolved out of a prior program, ACE, and ACE evolved out of an ancestor called Antistrat. That simply asks the question, like, what's the architecture of Antarctica?
It all started when Peter Barrett and Alan Cooper met me in Ricci in Sicily, in Italy. And we started talking about the next step in the SCAR research programs. And what they wanted to do was to think about the use of numerical ice sheet modeling in the context of Antarctic glacial history.
ACE had been about concentrating on the Antarctic system as a whole, climate, the evolving ocean temperatures, the ice sheet over the vast expanse of geological time. PACE really focused on the ice itself, the ice sheet. How much has it grown and shrunk? How many times has it grown and shrunk? And this transect concept emerged. We would have records of climate and what the ice sheet was doing from the continent itself, we would have like essentially a South Pole to the equator and even beyond into the Northern Hemisphere view.
IODP set out to help us with the transect approach so that we understood Antarctica up close and farther away, and then in the very distal records. What we've succeeded with in recent years is having new drilling records obtained from the Ross Sea and the Amundsen Sea and the peninsula, the new Wilkesland record as well.
We came to a much better understanding how the melting processes of the submarine-based ice sheets occur through incursions of warm water onto the shelves. During PAIS, quite a large group of people established a new database on the past topography and the past bathymetry, so water depth. And this database can be used now by climate and ocean and ice sheet modelers.
Thematically, without a doubt, the integration of field data and geophysical and drilling with modeling is the greatest contribution to PAIS.
What has really pushed PAIS forward in the last decade, and instant, as well, has been the linkage of data and models together, of drilling being able to get the records, the history of what has happened, and then this really started with Andrew to see the models try to recreate what the records are saying. It's the only way the models get sharper. The only way they get better is if they can be tested against the past.
Thanks to a lot of seismics, national seismic campaign and our international seismic campaign, the many geophysicists, they were able to provide a reconstruction of the evolution of the topography below Antarctica.
And I think over the course of PAIS, we have made, as a community, great steps in adding all kinds of feedbacks to the ice sheet models that predict future sea level rise, that make them much more sensitive to the atmospheric forcing. And second of all, by making much better constraints on past sea level conditions.
PAIS ended in 2020. A new SCAR initiative is born, Instant, that will focus on estimating instabilities and thresholds in Antarctica. Instant will consider all Earth components. Big science and challenges need human, technological, and logistical investment. PAIS and its predecessors demonstrated the benefit of joining efforts to obtain significant achievements. We now need more data from Antarctica to better constrain reliable predictions of future global sea level rise.
My hope for the Instant program is that it expands the approach that was developed for the PAIS program. This
My hopes for the future of Instant are that we kind of continue to promote, the next generation of scientists.
But to me, the exciting thing looking forward is really understanding what are the drivers of ice sheet change.
Increase our focus on the highest resolution records that can tell us about rapid change.
Data integration is probably something that's going to provide us some great insights and some discoveries.
Continue to foster a diverse, inclusive, multidisciplinary and international community like we started with.
PAIS has helped us.
When PAIS started,
PAIS has carried.
PAIS stands for
PAIS evolved out of
Past Antarctica sheet dynamic.
What does PAIS mean to me?
PAIS is the community that brings disciplines together of understanding Antarctica.